Here are a set of questions asked by Divya Kajuria. Let's go about solving these questions one by one. Okay, here's the first question. A mixture of 40 liters of milk and water contains 10% of water. How much water must be added to make the water 20% in the new mixture? So we have a mixture which contains 10% water, so just 10% of it is water, and the rest 90% is milk. This is 90% milk and 10% water. How much water must be added to make the water 20% in the new mixture? So with this thing we are going to mix water. So what is water going to contain? Water is going to contain just water, so that is 100% water, right? So we are adding 10% water with 100% water and are getting a resulting mixture which is 20% water added to make the water 20% in the new mixture. Okay, right, this is 20% water and 80% milk. So what are we supposed to find out here? How much water must be added to make the water 20%? So we are also given that we are adding 40 liters of this particular water and milk solution with x liters of water, and we are obtaining a solution which is 80% milk and 20% water. So we have to find out this x. So how many liters of water are we adding to 40 liters of this solution? That's what we need to find out. All these are relatively simple questions, but for the sake of better understanding, I'm trying to explain it as much as possible. So in the first case we have 10% water. To that we are mixing 100% of water, and we are getting a resulting solution which is 20% water. So this is our alligation table, and we also know that we are mixing 40 liters of 10% water with x liters of water. So this is our alligation table. This is 20 minus 10, which is equal to 10, and this is 100 minus 20, which is equal to 80. So this is nothing but 8:1. So this is 8 parts. This 8 parts represents 40 liters of the milk and water solution. Okay, so 1 part is equal to 5 liters, and here we are adding 1 part of water, so that is nothing but 5 liters. This is our answer. Let's move on to question number 2. Two types of alloys possess gold and silver in the ratio of 7:22 and 21:36. In what ratio should we mix these alloys in order to have a new alloy in which gold and silver would be in the ratio 25:62? So what do we have here? We have, this is alloy 1, this is alloy 1, and this is alloy 2. Okay, in alloy 1 we have 7 parts gold. Okay, this is alloy 1. We have 7 parts gold and 22 parts of silver. Okay, so how many parts do we have in total? We have 7 plus 22, which is 29 parts. Out of these 29 parts, we have 7 parts as gold. Okay, this is our alloy 1. And in alloy 2, what do we have here? We have 37 parts of silver and 21 parts of gold. So what are the total number of parts? Is 37 plus 21, which is 58. We have 38 parts, and of these 58 parts, we have 21 parts of gold. So these are two alloys, and when we mix them in a particular ratio, for example, if we mix alloy 5 kgs of alloy 1 and maybe 2 kgs of alloy 2, we may get a resulting mixture. Okay, we may get a resulting mixture, but we do not know the ratio in which we mix alloy 1 and alloy 2. That is what we need to find out. And if we mix alloy 1 and alloy 2 in a particular ratio, we'd be getting the resulting mixture, which is 25 parts, which consists of 25 parts of gold and 62 parts of silver. So we have total number of parts is 87 parts. Out of these 87 parts, 25 parts are gold. Okay, so this is going to be our resulting mixture. Now let's frame our alligation table. This is 7 by 29 gold in alloy 1 and 21 by 38 gold in alloy 2. When we mix these two in a certain ratio, we are going to get 25 out of 87 parts. Okay, and this is 29 and 87. LCM would be 87. 29 3s are 87, 3 7s are 21 minus 87. This will be 25, right? 29 3 7 so 25. Okay, so this would actually go the other way around. This would be 25 minus 21 by 87, which is nothing but 4 by 87. And here we have, this is 38 and this is 87. What's the LCM of 38 and 87? Okay, so sorry about that. This is 58. This is 5. Sorry about my bad handwriting. Okay, this is 58 and this is 87. We have 29 in common, which is 2, 3, right? So the LCM would be 6 into 29. What is that? 29 into 6. 174 is our LCM. Okay, this is 29 into 6 7s of 42. This would be 42 minus 58 into 3, which is 63. Okay, again this would be the other way around. This would be 63 minus 42, which is going to be 21, right? 21 out of so this is our this is what we are getting. We are getting 21 by 174 is to 4 out of 87. Okay, 29 3s or 87. This is 29 6. Okay, this is again 1, this is again 2. So what are we getting here? This is 21 is to 8. So this is 21 is to 8, right? We are mixing 21 parts. So what is asked here is to have a new alloy. In what ratio should we mix these alloys so that okay. Okay, I seem to have made a mistake here. Where is my pen? Okay, it is here. This is 174 and this should be 63 minus 50, so this should be 13. I'm really sorry about that. I know this is going to confuse you, but you do it yourself and you'll be getting the right numbers. No need to get confused. So this is the final ratio that I'm getting. See, in the left hand side this is 13 by 174, and on the right hand side I'm getting 4 by 87. This is the final ratio, 13 by 174 is to 4 by 87. Okay, 87, we can further simplify this. 87 2s are 174, and this 2 is going to go that side, so this is 13 is to 8. Okay, this is our final answer. So what does that mean? That means that we should mix 13 parts of alloy 1. For example, 13 kgs. How to mix 30 kgs of alloy 1 and 8 kgs of alloy 2. If we mix these two in this particular ratio, it is going to result in a third alloy, which is going to contain gold and silver in the ratio 25 is to 62. So that is our answer, 13 is to 8. Now let's go to question number 3. A mixture contains wine and water in the ratio 3 is to 2. Another mixture contains in the ratio 4 is to 5. How many liters of latter must be added with 3 liters of a former so that the resulting mixture may contain equal quantities of wine and water? So the first one contains 3 parts wine. So this is wine, the upper portion, and the lower portion is water, right? Water. Okay, so this is the first solution. Our first solution contains 3 parts wine and 2 parts water, and our second solution contains water, 4 parts of wine, 4 parts of wine and 5 parts of water. So this is our second solution. So we have 3 parts of wine out of total 3 plus 2, 5 parts. Out of 5 parts we have 3 parts of wine in solution 1, and out of 9 parts we have 4 parts of wine in solution 2. And when we mix these two things, how many liters of latter must be added with 3 liters of former so that the resulting mixture may contain equal quantities of wine and water. So what does equal quantities of wine and water means? Wine 1 part and water 1 part. So the total would be 1 plus 1, 2 parts. After 2 parts, 1 part is wine, right? So 1 by 2, we are going to get this particular mixture. So what is said here, how many liters of latter must be added with 3 liters of the former? So what I'm doing is that I'm adding 3 liters of solution 1 with x liters of solution 2. Okay, I'm adding x liters of solution 2. When I add them in this particular proportion, I'm going to get a new mixture which is going to contain 1 part wine and 1 part water. So I have to find out this x. So that is the question. This is again very simple. This is 6 minus 5, which is equal to 1 by 10, and this is 8. This is 9 minus 8, which is equal to 1 by 18. So this is my ratio. 1 by 18 is to 1 by 10. If I have to simplify this would be this. So 5 is to 9. So this is what I'm getting here. 5 is to 9. Okay, so I'm adding 5 parts of solution 1, 5 parts of solution 1 to 9 parts of solution 2. Okay, if I add it in this particular ratio, I'm going to get 1 part wine and 1 part water, and I already know that 5 parts is 3 liters. Okay, so what is this 9 parts? So 5 parts is 3 liters, so 1 part is 3 by 5. Okay, and what is 9 parts? Into 9, right? Into 9. So 9 parts is nothing but 27 by 5 liters. So to 3 liters of solution 1, I need to add 27 by 5 liters of solution 2 in order to obtain the resultant mixture. Okay, so this is my answer, 27 by 5 liters. Now let's go to question number 4. Okay, a shopkeeper bought 15 kg of rice at the rate of rupees 29 per kg and 25 kg at the rate of 20 per kg. Sold the mixture of both types of rice at the rate of rupees 27 per kg. His profit in this transaction is okay, let's come back to this question later. Let's go to the next question and then later come back to question number 4. Okay, question number 7. I already done question numbers 6 and 7, so I'm jumping to question number 7. So from a container full of pure milk, so when we say pure milk, how much percentage is that? It is 100% pure milk. Okay, 20% is replaced. So when I replace 20%, what does replacing means? Replacing means I'm taking out 20% out of 100. Okay, and I'm replacing it by 20% water. Okay, so if in the first occasion I have 100% pure milk, so what is going to remain when I replace 20% of that? Okay, what's going to remain is 80%. I'm throwing 20% out, so what is going to remain is 80%, right? So 80% of pure milk is going to remain after the first operation. Okay, and this operation is going to this process is repeated 3 times. So this is the first time, and I'm going to repeat this operation for further 2 times. So I'm going to contain some percentage of purity here. Okay, I'm not going to do, okay, I'm getting 80% pure milk. Okay, I'm getting 80% pure milk after the first operation, and I'm throwing 20% of it out, and what's going to remain? 80% is going to remain. Okay, so what's the purity of milk after the second operation? That is again 4 by 5, so 16 into 4, so 64. So 64% pure milk is going to be there after the second operation, and the same process follows the third time as well. This is 4 by 5 into 4 by 5, which is 80 by 100. Okay, so 5 12, so 60, 12.8. okay, 12.8 into 4, 49.2% purity of milk is going to remain. Okay, at the end of the quantity of pure milk reduces to okay, this is 51.2, I suppose. Okay, that is my answer. After 3 operations, the quantity of pure milk that is going to remain is 51.2%. we can simply do it like this. For example, I have 100% and I'm removing 20%, so what's going to be left behind? 80%. Okay, during first operation 80% of this is going to be left behind, and of that and during second operation 80% of what is left behind the first operation is going to remain, and in the third operation 80% of that is going to remain. So this is nothing but 100 into 4 by 5 into 4 by 5 into 4 by 5. Okay, so this is 25, this is 4, this is 4 so 16 256 by 5, which is 51.2 percentage. Okay, once you understand the basic concept behind that, this is cakewalk. Let's go to the next one. Where on earth is my mouse? Wow, I'm not getting my mouse. Okay, yeah, it is. Let's go to question number 8. To gain 10% on selling sample milk at the cost price of pure milk, the quantity of milk to be mixed with 50 kg of pure milk is... Okay, I'm mixing water with pure milk. Let me assume that milk costs me 1 rupees per liter, and I'm adding water that is going to cost me 0 rupees. Okay, I'm going to sell the resulting quantity at 10% profit. Okay, the resulting what would be the resultant price of mixing 1 rupee milk with 0 rupee water? I'm going to end up between 0 and 1, right? So this particular thing is going to be between 0 and 1. Let me assume this to be x, and if 110% of x is going to give me my cost price. My cost price is what? 1. So this particular x is nothing but 100 by 110, which is equal to 10 by 11. So this is my x. So x is equal to 10 by 11. Now let's do our allegation. So this is 1 by 11 here, and this is 10 by 11. This 11 and 11 gets cancelled, and what I am left with is 10:1, and it is given the quantity of water to be mixed with 50 kg of pure milk. So I'm mixing 50 kg of pure milk with let me say a quantity of water. Okay, I now know the ratio in which I'm going to mix, which is nothing but 10:1. So if 10 parts is 50 kg, 1 part is 5 kg, right? So I'm going to mix 5 kg of water with 50 kg of milk. So this is my answer, 5 kg. Let's go to question number 9. Two vessels A and B contain milk and water mixed in the ratio 8:5 and 5:2 respectively. The ratio in which these two mixtures must be mixed to get a new mixture containing 900 by 13%. This is a very simple question. Okay, so say example, if we say 5%, what does that mean? That means 5 by 100. So when we say 900 by 13%, what does that mean? 900 by 13 into 100. Okay, so this is 9 by 13. So we have two vessels A and B which contain milk and water in this ratio. So in first vessel I have 8 parts milk out of total 13 parts, and in the second container I have 5 parts milk out of 7 parts, and when I mix these two things together I'm getting 9 parts milk, and the ratio in which we mix to get a new milk, 9 with 13. Okay, 9 parts milk out of 13 total parts. Okay, let's do allegation. This is 1 by 13, this is 91, This is 63, this is 65 minus 63, which is 2 by 91, and this is 1 by 91. So this is 1, this is 7, this is 2 is to 7. That's my answer. Let's go to question number, I have to scroll this one, I suppose, before going to, okay, yes, let's go to question number 10. In what ratio must water be mixed with milk to gain 20% by selling the mixture at cost price? So let me assume that milk is going to cost me 1 rupees, and I'm adding water which is going to cost me 0 rupees, and I'm going to get a resultant mixture. Okay, and I'm going to get a resultant mixture. And what is said is here is that if I sell this resultant mixture at 20% profit, that means if I 120% of this resulting mixture gives me the cost price of milk, gives me the cost price. What's the cost price? What is it going to cost me? It's going to cost me just 1 rupees, right? So if I mix milk and water, I'm going to get a value that is going to lie between 0 and 1. Say the value would be 0.75 or something, and if I'm going to sell it at 20% profit, okay, I'm going to get my cost price, which is 1 rupees. So from this we can say x is 100 by 120 or 5 by 6. Okay, we have our x. Now let's do our alligation. This is 1 by 6 and this is 5 by 6. So in what ratio must water be mixed with milk to gain is 5 is to 1. Okay, that means I have to add 5 parts of milk, okay, and 1 part of water. Or let's say that I can mix 5 liters of milk with 1 liter of water and sell the resulting mixture, and if I sell the resulting mixture at cost price, I'm going to get 20% profit. Let's move to question number 11. Tea worth rupees 126 per kg and rupees 135 per kg or mixed with the third variety in the ratio 1:1:2. If the mixture is worth rupees 153 kg, so have this resulting mixture which is 153 kg. Okay, and I'm mixing tea, this is T1, this is T2, and there is T3. T3 is X rupees. I'm taking 3, 2 as X rupees. So I'm adding T1 and T2, 1 part of T1 and 1 part of T2 and 2 parts of T3. Okay, this 1:1:2, I'm going to take this 1:1:2 as 1 kg, 1 kg, 2 kg. Okay, how many kgs do I have in total? 2 plus 1 plus 1, which is equal to 4 kg. Okay, so 1 kg of T1, which is 126 rupees. So 126 into 1 kg plus 135 into 1 kg plus X rupees into 2 kgs. Okay, we shouldn't forget that. Third quantity is 2 parts, 2 kg, and I have my total kgs as 4 kgs. So if we do this operation, we are going to get the mean price, which is 153 kgs. So what is this? 125 plus 125, 250, 261. Okay, this is 261 plus 2x by 4, which is equal to 153, which is equal to, this 4 is going to go this side, this is 300, 612. So 261 plus 20, 2x equal to 612, 2x equal to 612 minus 261, which is 15351. So x is nothing but 175.5 rupees. So that's the cost of a third variety of tea. So it is in option. Okay, I think all the options are wrong. The third variety of tea is going to cost you 175 rupees 50 paise. That's going to be your answer. Okay, I think we have one more question pending, right? We have question number 4. Okay, a shopkeeper bought 15 kg of rice at the rate of rupees 29 per kg and 25 kg of rice at the rate of rupees 20 per kg. He sold the mixture of both types of rice at the rate of rupees 27 per kg. Is profit in this transaction? So they are saying that he profited by this transaction. So let's do our allegation table. So where is the price? 29 per kg and 20 per kg. Okay. He mixes 29 per kg rice with 20 rupees per kg rice. Okay, in what ratio does he mix? And first rice is 15 kg, the second rice is 25 kg. So he mixes them in the ratio 3:5. Okay, and he gets a resultant mixture which costs x rupees. So what's our allegation table? 29 minus x, this is x minus 20 by 3, which is equal to this is by 5. So this is 5x minus 100, which is equal to 3 is 90, 87 minus 3x. So this is 8x, which is equal to 187. So x equal to 187 by 8. So this is going to be the price of my resulting mixture. Okay, so this is going to be the what is this cost price. So this is going to be the cost price of the resulting mixture. So how many kgs of rice are there in total? There is 15 kg plus 25 kg. So we the total is 40 kg of rice, and his cost price is going to be 187 by 8 rupees per kg into 40 kg. Okay, this is rupees into 40 kg. So what is that? This is into 5. Okay, his cost price is 935 rupees. What's his selling price? He sells them at 27 per kg. Sells 27 per kg. Okay, this is 27 per kg, and he sells 40 kg of it. So 27, 54, 108. 180 rupees is going to be his selling price. So what's his profit? Selling price minus cost price is his profit. So 1080 minus 935. So what does that come to? That comes to 145 rupees. Okay, so that's our answer. So I think we have covered all the 11 questions asked in this sent to me. So that would be the end of this particular video session. Thank you guys.